Hello and welcome to this tutorial video on composing with OpenMusic. Today we'll be looking at a related collection of OpenMusic functions, the BPF, BPC, 3DC, and we'll get into what all of that means. So I'm going to pull over here to a new patch and make a couple of new objects. So each of these are ways of working with some kind of basic lines, figures, from time to time trajectories or paths in OpenMusic. And the first one that we'll look at is this BPF item here. This is a breakpoint function. And so if you double click on that factory, you can see that we get just a basic line. And if you click on this pencil, you'll find that you can actually edit this line here and just kind of do whatever you want with that. You can go back to the cursor, and if you hit Command A if you're on a Mac, not sure about on Windows, you can select this line, and you can actually see the points that are used to define the curve. You can move it around if you want, or delete it and reset. And notice down here at the bottom, we have this optional little dialog here for the precision with which we are drawing or rendering this line. So if you click here and drag, you can specify the number of decimal points that OpenMusic will calculate when rendering this line. And so I've changed it to 5. You'll notice too that our axes here have shifted. We can't quite see it on the left-hand side, but we do have 5 decimals, and we do as well at the bottom. And if I go now to redraw it, we'll actually see much more finely graded curve. And if I select my selection tool here for the editor, hit Command A, it doesn't look like it, but I think we do have more precisely defined points, even if we don't have more of them. All right, so I think that's just about all for the editor. Maybe the last thing I would say, of course, you can overlay a grid if it's very important to be comparing the points of your curve with the values. And also you can resize by clicking along an axis and dragging, and that will change the amount of the overall Cartesian plane that you're viewing at any given time. So one limitation that we have with this breakpoint function object is that we can't do things like draw a circle, for example. You'll notice if I try, I don't have a whole lot of success. Let's reset all of this and give it another go. And it'll do its best, but you'll see what we end up with are these strange spikes where OpenMusic is attempting to match these values, and it's not quite working. So if you remember back to maybe basic algebra, where we discuss things like relations and functions, you'll remember that for a function we have a unique value mapped onto every input of the function. So where the x-axis is representing the inputs of this function, OpenMusic is only permitting for there to be one vertical value assigned to each. So to overcome this limitation, we can use this next object. Here we have the breakpoint curve, and if I open this up and begin editing, we'll see very quickly that you can indeed define whatever sort of curving loop-de-loop, polar coordinate or parameter you want, and it does provide a lot of freedom It's very handy, and in a moment we'll look at some cases where this could be uniquely useful. For now, you'll notice that it's mostly the same as the breakpoint function editor. We can change the precision. One thing that I would point out is if it's important for you to have this curve start and begin at the same point, you can specify here with this tick box that it be a closed curve. And if you want, you can go back then and edit, continue to change, and OpenMusic will ensure that it always returns back to the point where you started, producing a closed curve. And lastly, I'll pull up this last one, the 3DC. Let me pull up the documentation so I specifically know if that stands for, yeah, okay, 3D curve. Excellent. So at first, this editor looks maybe a little bit different because it starts with a sort of viewing pane here where we see three-dimensional space. But we can do basically the same editing that we did with the 3DC in each of these different Cartesian planes. And they're labeled in the bottom left corner so that you can see. So we've got the YX plane, the ZY plane, and the ZX plane. And we have the same tools that we had in each of these other editors. And we also have the ability to define the precision. We can also specify aspects of the space too, which is handy. So we can hide or show the axes. We can hide or show kind of the boundaries of our three-dimensional space. And then as we're actually adding curves, we can change their width or their color. So just some helpful little things. But maybe for the moment what I'll do is I'm going to change this precision back down to 0 decimals. And I'm just going to begin drawing here. And you'll see now we actually have this curve appearing in our room. And let me see if I remember. Yeah. So what I'm doing at this point is I'm holding down Shift and scrolling with my trackpad to resize. So so far, the curve only extends in the ZX plane, because that's the only one that I've been editing. And so if we look at our YX plane or our ZY plane, we just have a line. We don't really have any extent showing how the curve would fill up any of these Cartesian spaces in both dimensions. So what I can do is I can identify where I ended in the ZX plane here with this red dot and hop over to a different plane editor and continue editing in that one. So now we can see, to begin with, I was editing in this plane, the ZX plane, and I've continued editing now in this plane, the YX plane. And I can do the same thing with the ZY plane, continue editing. And if I want to get back to where I started at some point, all I need to do is ensure that the red dot is aligned with the blue dot in each of these planes. So I can pull them in, and now we've got what basically amounts to a closed curve in three-dimensional space. And of course, if I wanted to, I can select all of this, delete it. I could work with two decimals of precision and define, far more richly nuanced curves and use those. So the next thing that I want to point out is that all of these parameters that we have been manipulating in the editor can be set and manipulated by way of these inlets. So let's check the documentation for the breakpoint function, and we'll see that, as we would expect, we can pass a breakpoint function to a different breakpoint function using the self inlet. We can specify a list of x coordinates, and we can specify a list of y coordinate values, as well as the precision in terms of decimals. So what I'll actually do, let me pull these over and pull this down and resize it. And I'm going to type M so we get a preview of the window. And over here, I'll set up an arithmetic series, and we'll use that for creating our x points. So we'll start at 0, let's go to 100, and our step size will be 1. So if we evaluate, so far nothing has changed. That's basically what we already had. But what I can do now, maybe I define another arithmetic series, define another one that goes from 0 to 30, stepping one at a time, and another one that goes from 30 back down to 0, stepping -1, and then I'll x append those two so that our resulting list goes all the way from 0 to 30, back from 30 to 0, and make those our y values. Almost. And if I evaluate now, we've got a nice little figure there. And it looks like it extends the pattern all the way down. So, that's interesting. In any case, you can see how you can use these inlets to very precisely specify the patterns that you are creating with the breakpoint function, as well as the breakpoint curve. You can do the same thing. And again, if I wanted to, I can specify a higher level of precision. It won't really affect the display of this factory box in this case, but in some cases it actually does. And sure enough, our precision has already been changed here to 3 decimal points. So the same goes for the breakpoint curve, and I believe all of those inlets are basically the same thing. Yeah, basically the same for those two. I think the difference comes with this 3D curve. So let me check the documentation for that. We've got one further inlet, of course, to specify the z coordinates, and that's really the last basic difference for that. All right, so I'll pull up now an example that I showed in a prior video, but that might be helpful to return to specifically for looking at these breakpoint curves, functions, and 3D curves. So I'll pull up this one in particular. And in this patch, what I wanted to do was specify a certain number of random points. In this case, I've got 7 of these random points identified with these little red circles. And I think of those as kind of landmarks. And I'm also specifying trajectory. So I begin at this blue point here in the center and proceed to the red point. And in this case, I wanted to define a segment of a spiral. And so I opted to use breakpoint curves in this patch as opposed to breakpoint functions. Because we can see there are a couple of values here at the edge of this spiral where a number of y coordinates are corresponding to a particular x coordinate. So here, I don't know if you can see in the display up at the top right, our x value is about 17.4, and here we've got another x value, 17.4 thereabouts, but we do have 2 different y values. So to implement this patch where the trajectory could, in a sense, double back on itself, I needed to make sure I was using a BPC rather than a BPF. If we take a look at the part of the patch that's actually doing the work of drawing these various curves, let's see. Yeah, so we've got this part here, which is kind of automatically producing breakpoint curves based off of the x and y coordinates for the random landmarks that are provided up here in this patch. And each landmark is actually its own breakpoint curve. So the result of this mapcar function will be 7 BPFs, each of which contains a single point representing each of these landmarks. And all of those are collected into this factory box down here. Let me make this a little larger. And this is a BPC library. So if you remember earlier videos, for example, where we use a number of voice objects and collect them into a single poly object that serves as a sort of library of voices, this is an analogous OpenMusic object, where basically this is storing or displaying a collection of BPC objects in OpenMusic. All right, and let me check to see if I have other instances where I'm using those. Yeah, so here we're taking a couple BPCs, and this is actually the part of the patch that is responsible for calculating the distance between subsequent points along the trajectory and the various landmark points. And let me see, let's go over to this other patch that's responsible for producing the trajectory. And yeah, this is great. So here we see I've got a couple of arithmetic series objects in OpenMusic. And then I'm using this very handy conversion. And in this case, what it's doing is it's specifying, I believe, azimuth and distance. Let me check on that with the documentation. Yes, azimuth and distance, where azimuth is, in terms of, I think, polar coordinates. What's the term I'm looking for? Azimuth is the number of degrees off of the x-axis, and distance is just the distance from the origin in a Cartesian plane. And it's converting those two values into x and y coordinates. And so we can see that here in this spiral. And like I mentioned earlier, it was critical that I use a BPC object rather than a BPF, because again, we've got multiple y values corresponding to any given x value. The last thing that I'll mention here is that these OM sample functions can be very useful. And so in this case, I wanted to calculate this spiral very precisely. And I forget exactly how many points along the spiral I have. But if I remember, yeah, it gets pretty dense here in the beginning. So what these OM sample objects do is, no matter how many steps I'm using to define this spiral, here I've got 3600, I can, after I've done the calculation, I can sample that down to a more reasonable number of points along the curve to use in subsequent calculations. The last thing that I'll mention with this patch is not only were BPC objects very useful and very helpful for defining these little landmark points or defining trajectories along this segment of the spiral, but they were also helpful in producing this figure up here in the top right, which actually shows the relative probability of each of these landmarks being used to calculate the pitch content of the final result of this patch. So this is a BPC library, and here you can see each of these is at some level referring to the distance from any given point along the trajectory to each of these landmark dots that we saw earlier. And this patch took the probabilities that were counted and turned them into BPCs. And yeah, so that was a helpful way of just getting some very quick analysis of how the pitch content of the resulting musical material is changing over time. So all of this is to show that you can do a lot of really wonderful and interesting things with these various factory objects for defining functions or curves or three-dimensional curves. And if I wanted to, I could go back and even rework this patch or its other related patches with three-dimensional points in space and a three-dimensional trajectory as well. So there are some really very powerful things that you can do in OpenMusic. Once again, I hope this has been a helpful video, and I hope it perhaps inspires you to explore some of these functions and objects in OpenMusic. If you have any questions or comments, if you have any suggestions for ways to improve any of these patches, please let me know. And if you want to be aware of similar content in the future, I'd encourage you to like or subscribe. Thank you again for watching, and I hope to see you in subsequent videos.